How are you? Hey, good morning, Levi.
Good morning.
I hope you're all doing well. This morning it looks a little bit sunny outside, so that's good. Warm up a little bit. Let's get started. So, we are doing more exponential functions, and this is the third lesson in the unit. It's called modeling with exponential functions. Today we'll be looking at finding the percent change in a exponential function or in an exponential function word problem. So finding the percent change, and that means what percent of value decreased or increased before and after. And then we'll look at the formula for growth and decay, and we'll do some examples. Formula for growth and decay for exponentials. And then we'll look at interpreting exponential growth and decay. So just being able to pick apart a problem and find all the different parts we need. Okay, we've got Anthony joining and Robel. There we go. Good morning, Anthony and Robel.
How doing, sir?
Hello, how are you?
Good, good.
Good, thanks for joining. Here we go. Here we go. So there's what we'll be looking at today, and we'll start in just a moment. Before we get started, let's look at our calendar again. This is the same one I sent last week, except I did add some details. Okay, so here's today, the 10th. Monday, the 10th. This calendar, I don't have Saturdays and Sundays. It's just the week, just Monday through Friday. So last week, we did the first two lessons, graphs of exponential functions. We did that on Tuesday and Wednesday. Thursday, we did the second lesson, transforming exponential functions. So that's done. Today, we're doing the next lesson, modeling. I'm going to give us 2 days for this lesson. Then notice that we don't have class or regular meetings on Wednesday, Thursday, and Friday of this week. We're doing achievement chats. So there's not going to be math class, and you need to set up an achievement chat with your teacher, your regular independent study teacher. So we only have 2 days of class this week, unfortunately. Next week, there's no school on Monday, the 17th, for everybody. That's Dr. Martin Luther King Jr. Day. So we're not doing any meetings at all next Monday. And then we're coming back Tuesday, the 18th. We're going to do our last final lesson right here. And then we'll take a day to review everything together. And we'll take our test on Thursday, the 20th. Then right away, we're starting Unit 6 on Monday, the 24th, down here. That unit will be done in the new month, month 7, but we need to start then. That's when our principals told us to have the new semesters beginning. Any questions, concerns about the schedule? Before we move on, I want to see or hear some confirmation from everyone that you've seen the schedule and you're ready to start. So can I have you just turn on your camera and show me a thumbs up, or give me some confirmation in the chat that you understand our schedule for this week and next week. Savannah, I appreciate that feedback. Am I missing anybody? Levi, I'm sorry I missed you. Thank you. I got you too. Anaya, Brooke, Anthony, and Robel. Brooke, thank you. I see that. Anthony and Robel, do you two have any questions about the schedule? Oh, Anaya, I just want to know that you've seen the calendar and if you have any questions about it or if you don't. So if you don't have any questions, can you please just confirm that you understand our schedule this week and next week? Thank you, Anaya. Thank you, Anthony. Okay. And you know what? Later today, I'll send out this calendar again just in case if that's helpful. So I'll send it out through the chat and email. Okay, let's get started on our exponential modeling. Okay, here we go. So this first topic is called the percent change. So we need to figure out when we're dealing with an exponential function, what is the percent that it's growing or decaying? So remember, growth means it's getting bigger, obviously. Decay means it's getting smaller. So if it's a growth problem, its graph would be this style. Those are the kind we started with. Decay are the reverse of that, where it starts off high, but it then decreases. It kind of gets flat going forward. We need to figure out what is the percent in any of our given problems, questions, that it's growing or decaying. We have a formula for this. So the formula we're going to use is this. The percent change is equal to this fraction, the final value minus the initial value divided by the initial value. Make sure you have this in your notes. This formula should be, This formula should be written down. I want you all to have this. And then we'll look at some questions with it. So percent change is equal to the final value minus the initial, then divided by the initial. Remember, initial kind of means like starting value. So every time we have to figure out percent growth or decay, percent change, we're going to be looking at two different values, the final and the initial. Starting value, ending value. Let's look at this table and calculate a few percent changes to see how this works. So this table is the graph of the same exponential we've been using. So or I should say f of x. F of x is equal to 2 to the x. So it's our most basic exponential graph function. So to figure out the final initial value and then the percent change, we're going to focus just on the f of x's, so like the y values. Remember f of x and y, same thing. So let's look at from here to here first. So let's make 1 our initial, and then 2 will be our final. When we figure out percent change, you're only dealing with one starting or initial value and then one final. So we're not going to look at all of them at once. You only do it for a snapshot of before and after. So for this, our final value is 2. The initial value is 1. And then we divide by 1. 2 minus 1 is 1. 1 divided by 1 is 1. So we got a percentage of 1. Now, as a percentage, this would be 100%. Let's do another one, and we'll probably see it come out as a decimal. Let's go from now 2 to 4. I'm going to change the color to kind of differentiate. So now I'm going to make 2 my initial for my second example, and 4 will be my final. So if we were to have started counting here and then ending at the next one. So this time the numbers will be different. Let's see what we get for our percent. So the final is 4. Initial is 2. Initial is also 2 underneath. So 4 minus 2, and then 2 over 2. So this also came out to 1, and this would again represent 100%. Now, it's coming out to 100% each time, even though the numbers are changing that we're using. And that's correct. We should always get the same percent change no matter which sets we looked at to figure it out. Let's do a third one real quick. Let's look at 8 to 16. So a third example, and we should get 100% again. We should get 1 again. So now we'll look at 8 as our initial and 16 as our final. Even though the spread is getting different, right? It's much more of a spread in between them. Let's see what happens when we still calculate percent change. So final 16 minus 8 initial over 8 for initial. So 16 minus 8 is 8. 8 over 8 is 1 again. Okay, now usually though we will get a different decimal. So actually, let's do a couple other examples. Same type of problem, just finding the percent change, where we get different percentages that aren't just 100. Okay, it'll be modeling a different function this time too. So here's something I took from Edmentum. So it says at the top, match each set of prices with the correct percentage of increase or decrease. And then if you were doing this in Edmentum, we'd be dragging the tiles, the percentages down into the different word problems we see below. So let's look at the word problems and not worry about the tiles yet. Then we'll just look for the correct tile when we solve it. So I'm going to label these like problem 1, problem 2. There's 4 different questions here, 4 different examples. So looking at example 1, the price of a popular doll is $29 before the holidays and $23 after the holidays. So initial means starting, final means final or ending, last one. So this will be our initial before the holidays, and then our final price for the doll is after the holidays. So we need to use our formula again. Final minus initial over initial. So that would be 23 minus 29 over 29. Try solving this one on your own for me. When you finish, you're going to get a decimal, and we'll talk about that. So take a moment and do the subtraction and then divide by 29. And if you can tell me in the chat what you get, we'll compare our work together. Do the subtraction first and then divide by the 29 in the bottom. 23 minus 29 over 29. Okay, so no one's found anything yet. Let me show you how we would do this one. 23 minus 29. Try that in your calculator. What do we get for just the subtraction? Will you do that for me and tell me what you get, please? Just put it in the chat. 23 minus 29. Kind of a two-step deal. I see two people put something in the chat. Anaya and Savannah, thank you. You both got -6. Yeah, that's what I got. Thank you.
So I think it's gonna be -6, but I think wait. Okay, I'm settling with -6. I was gonna say +6.
Totally. Good, good, good. I'm glad you went to that 6 because that's the space between 23 and 29, or 3 and 9. Good job. Because the 29 is negative, and it's like the larger of the two numbers, 29 or 23, then that means the leftover is negative. Good job, Levi. And to all three of you. So on the top, our numerator is -6. Then it's divided by 29. Now, I want you guys to try that in your calculators next. Use a calculator. Use Google Calculator or your phones. Do -6 divided by 29. And we're going to get a decimal. Tell me what you get, please. Okay, good. I see someone answered. Let's see a few more of you put your answers in, please. Savannah and Anaya, good. And you both got the same thing. Let me show you how to do this. Just you two did it correctly, but just so that we all know how to do it, I want to look at it real quick with you. If you use the Google calculator, our -6 divided by 29. Cool. And I think that's what you both put in the chat, -0.20. And then it goes on, right? There's more number, 689. When we're talking about percentages, when we're talking about percentages as a decimal, like we're doing now, we really are looking at the first two numbers that we pass the decimal. That's out of 100. So let's see here. Let me quickly take this. Okay, here's what we found for that first one. So up at the top right, here's what we got when we divided. -0.206. So for this problem, you could say it's -20%. The first two numbers after the decimal are out of 100. That's the percentage. However, because we're kind of capping it there at those first two numbers, we need to do our rounding. So that's where we look to the number to the right, and then you ask yourself, is this bigger or smaller than 5? And you round up if it's 5 or bigger, and you keep it what it is if it's 4 or smaller. So because this is 20.6%, 6 is bigger than 5, we're going to round that up to 21. So for this answer, we would say -21. Now, none of our answers say negative, right? It's either decrease or increase. So because it's going down -21%, then this is a decrease, 21% decrease. Remember, we're either dealing with a growth function where it's getting bigger or a decay function where it's decreasing and getting smaller. And if we look at the story again, real quick, it's 29 here before Christmas, $23 later after Christmas. it went down in price, so we know it's a decrease. And another clue is if you get a negative like we did in this first answer. Let's look at the number 2 question together. The price of milk in Wisconsin changed from $3.09 per gallon to $2.16 per gallon. Because they've set it as it changed from 3 to 2, that's our clue that this is initial, and this 2.16 is our final. Let's set this up and do this one together also. Okay, I'm going to draw a line here for our new work above. So it's final minus initial over initial. Final is 2.16. Initial is 3.09. And then we divide by 3.09. Okay, first do the subtraction on top. So in your calculators, 2.16 minus 3.09. And again, we get another decrease. It's negative 0.93. And then in the denominator, that hasn't changed yet, 3.09. So now we have to do the division. Now divide. So keep that top number and then hit divide 3.09. Divide 3.09. Okay, and when I hit divide, oh, someone's got it in the chat. Nice, thanks, Anaya. And I got what you got. I got negative 0. And I'm going to write out a few more, 30097. If we're looking for just 2 digits, because look at all of the answers above, right? It's like 21, 21, 43, 2 digits, 2 digits. So that's our clue that we're kind of rounding it off to the first 2 digits, which are out of 100. So good. And we look to the number on the right, that second 0, that is less than 5. So that means we keep this 0 the same way it is. Negative 0.30, like Anaya said in the chat. And as a percentage, those numbers are 30, 30. So that's a decrease of 30%. Let's see if we get a positive one next for an increase instead of decrease. Concert tickets. Number 3, the price of a concert ticket is $76 if purchased before the concert. The price changes to $99 if purchased the day of the concert. So our initial is 76, and after or final is 99. And you can tell that this is a growth, so it'll be positive this time, and it'll be an increase this time because it's going from 76 up to 99. So I'll do that work right here next to the writing. Final minus initial over 76 over the... Oh, wait, I did that wrong. I hope you caught that. Final minus initial. Final... Yeah, okay, maybe I didn't do it wrong. Forgive me. 99 minus 76. Yeah, that's correct. Over initial. Okay, so 99 minus 76, then divide by 76. Do it with me. Check your work so we're all on the same page. And check my work as well. 23 on top over 76. And here we got a positive finally, 0.3026. And it goes on. But if we're looking for just the first 2 numbers, it's probably going to be the 30 or 31. Let's just talk rounding, folks. Practice our rounding skills. Is this going to round up to 31 or does it stay at 30? Anyone want to take a guess at this? Chat or Mike? Round up to 31 or keep it at 30%? All right, I see an answer in the chat. Keep it at 30, Anaya? Yes, we're going to keep it at 30. Why do we keep this one at 30 and not round it? Because the number to the right of where we're cutting it off, the 2, is less than 5. So that means keep the 30 as 30 and don't round up. This time, we're using an increase because it went from 76 up to 99. Our percent change was positive. So that's our clue that we're dealing with an increase. Awesome. And our last example. The price of a hotel room is $125 a night, but changes to $145 per night for upgraded amenities. So for more stuff in the room. All right, but we're not worried about that. Let's just look at our numbers. Initial, final. Our clue is that it says $125 a night, and that's the price, but it changes to. So after changing is final. So that means we're going to have 145 minus 125 over initial 125. Okay. You do it with me. Check my work. 145 minus 125, 20. Okay, 20 over 125. Okay, this one came out to a nice clean decimal, 0.16. That's nice. No rounding, no even thinking about rounding because there's no more numbers, no more digits. So this is going to be 16%. Is this an increase or a decrease? Increase or decrease for number 4? Any thoughts? Double check your initial going to final. Initial means like starting. Remember, initial, think starting. So if it starts at 125, ends final at 145, did that climb and go up, or did it decrease and go down from 125 to 145? That's one way to figure out if it's growth or decay, increase or decrease. Another clue that we can use, when you find the percent change, is it positive or negative? We found 0.16. It's positive, right? It didn't have the minus sign, the negative sign. Because this is positive, that's our clue that this is an increase, 16% increase.
I'm pretty sure it's an increase.
Nice. Levi?
Oh, I already read it.
I just put it up right as you were talking. Anaya and Levi, thank you both for helping me with that. And Savannah, too, for doing some in the beginning as well. Okay, so let's see what we've got next. Are there any questions right now on these 4 problems or on percent change? No. Okay. Pardon me. Okay. All right. Well, then next up, we're going to still be using percent change. But we're also going to be looking at writing the whole function for different exponential functions. So we knew from last week that exponential functions always look like this. F of x, that's like our y, equals a number to the x power. So that's from last week. And we played with other functions as well where it's not 2, right? But that's the basic layout. Below In black, this is our general form of all exponential functions, and it's the one that we're going to use to find growth or decay of different scenarios. So copy this down. Make sure you have this black formula written down in your notes. Now let's add to it as to what all the different parts are. All right, let's start with the little r on the inside. So I'm going to draw some lines to these different variables, and then we'll label them and describe a little bit about them. So the r that we see is technically that means the rate. It's the same thing as what we just were solving for, the percent change. So r is percent change in decimal form. So we have to keep practicing going back and forward from percentage to decimal. So R is the percent change in decimal. A, the capital A, that stands for the initial amount. A for amount. It's the beginning amount, the initial amount. The f of x, the y, the output of the whole function, this is the final or ending amount. We often, I think in our work, we're not going to be dealing with final ending amounts in the formula like this. So we're not going to have a number for them in the formula. Sometimes you do in curriculums, but everything I saw in our Admentum work doesn't give you a final ending amount when you're doing a formula. Just an initial and a rate. And then x, the variable x, is our input. That's what we're going to be plugging numbers into. It stands for time. So in all of our word problems, it's always going to be a certain number of weeks or months or years or something like that. So it's always a measure of time. Days, weeks, months, years. So if we know how much the initial amount is, so how much of a certain item we're starting with, if we know what the percent change is, the rate, whether it's going up or down, and what the decimal is, then we can plug those two numbers in to this formula and solve for how many there will be after a certain amount of time. Okay, I'm going to hold it on this screen for another moment, a couple moments while you're copying down, because it's very important that you have the black formula and all the labels so you know what all the different parts are and where they go. Okay, now let's look at some examples. For these examples, we're not solving the formula for a certain time. We're merely setting it up. So plugging in all the parts where they go in the formula. So it's the same format as the last examples we did. We've got three examples below. I'm going to label them 1, 2, and 3. And we're just merely picking from above which is the correct formula for that scenario. All right, and I'm going to actually write the generic again above in red to we can use as a reference. Okay, so let's look at example 1. The price of gas, which started at $2.56 per gallon, increased at a rate of 4% per year. So our goal is just to write the formula for this. initial amount is $2.56. It says that the price of gas started at this. So because it says started at, that's our clue that that's the initial amount. Increase means our rate will be positive. And then the rate itself, R, is 4%. Now, how do I write 4% as a decimal? Remember, the percent number is over 100. So if I need to write 4 as a decimal, you can put it over 100. That's a fraction. Then do the division, and what do you get in your calculator? 4 divided by 100. 0.04, like this. 0.04. Remember, the first two numbers are the ones over 100, and the first two numbers here are 0.4. If you had written 0.04, if you had written just, side note up top, 0.4, this is actually 40%. So if it's a number like 4%, it'll be 0.04. So this is going to be our decimal we use for R. So now we need to put it all together in the formula. F of x is equal to 2.56. That's my initial amount. Now, remember the formula is 1 plus r. So I'm going to do that work on the side. 1 plus r, that's 1 plus 0.04. So 1.04. So that's what we should see in the parentheses. And then it's to the x power. Now I realize this has a lot of decimals in it, but I'm hoping that you see the connection between this formula we just wrote and the one we were using last week. 2 to the x, right, was the one we used a lot. The base here is 1.04. And then you would raise 1.04 to the x power if we were plugging in a number for x, and then times it by 2.56. But the base, like we used a lot last week, is 1.04. It's whatever's in the parentheses. All right, let's look at number 2. The chess club started with a membership of only 4 students, but the membership grew at a rate of 2.56 each week. So, what does it sound like is the initial amount this time? 4 or 2.56? What's the initial amount? What's the starting amount? Any ideas? Any thoughts? Please. In the chat. Savannah, 4. Very good, Savannah. Keyword, they did say started with a membership of 4. So that's our clue that that's our initial. We're measuring how many people, students, are in the club. So writing our formula, it's f of x equals 4 times 1 plus our rate. Now here, this is a little tricky because they're giving it to us as a percent. It has the symbol, so that's percentage, but it's also a decimal. So to convert from percent to decimal, the safest way is always put it over 100. If it's in a percentage as it's given to you, divide that by 100 for the decimal. 2.56 divided by 100. And this is going to give us 0.0256. And that's the rate. And we still need to add that to 1. That's in our formula, right? It's 1 plus the rate. So now in my parentheses, 1 plus r, that would be 1.0256. and to the x power. Don't forget that. Cool, and I see that option above right here. That was our answer if we were dragging it down from above. Thanks, Savannah, for your help. Let's do number 3. A forest started with 256 maple trees, so that's our initial. And the number of maple trees increased at a rate of 40% each year. So this function would be 256 for starting amount, initial, increased at the rate of 40%. So 40 over 100, 0.4. 40 comes out to just 0.4 as a decimal. Remember to add 1, 1.04. That's what's going to be in our parentheses. Now, we should do a decreasing function. And foolishly, I just assumed that one of these was going to be decreasing. So let's do a fourth example together right here. I'm just going to make one up with you for a decreasing function. So let's say that we start let's say we were doing something with money at the bank. So let's say we started with actually, I'm sorry, not money at the bank. What's something that would be decreasing? How about the value of a car? So my car is worth, when I bought it, let's say it was worth, I don't know, $12,000. I bought it used. And you've probably heard before how as soon as you drive a car off the lot, it starts decreasing in value. It's not worth as much the next day as it was when you bought it. And unfortunately, that's true. Cars are always losing their value. The older they get, the less it's worth. So let's say that my car is worth $12,000 to start with, but it decreases. And I'm making this number up, so don't assume that this is the way that they always decrease. Let's say it decreases at a rate of 0.5% each year. Okay, I'm just making up these numbers, so don't quote me on this. But my car is worth $12,000 to begin, and then it decreases at a rate of 0.5% every year. Let's write the formula for this. I want to show you one with a decrease, with a one that's going down. So we know how to start. F of x is equal to the initial, 12,000. Now, my formula is 1 plus r. I'm going to just put it in as 1 plus r for now. My rate is 0.5%, right? That's what we started with here. But remember, it's decreasing. So a rate, let's figure out what the actual decimal will be. 0.5%, convert the percentage by dividing that number, all of it, over 100. 0.5 over 100. 0.005. So as a decimal, this is 0.005. So this is my actual rate. And because it's a decreasing, we know that decreasing rates are negative. So we're going to put this into our formula. 12,001 minus the rate we just figured out. If it's a decay, a decreasing function, it's always going to be 1 minus the rate. Let's see what that comes to. Do that subtraction in the parentheses with me. 1 minus 0.005, 0.995. So here's our function. Initial amount, 12,000 times 0.995. An interesting note, for all the first three examples we did, it was always 1 point something, right? 1 point the rate. For decreasing, we'll always have a 0 point. Will be 0 point something, 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 whatever the rate is. If you multiply anything by a number between 0 and 1, like this is, it's going to decrease it. Okay, now the last thing I wanted to look at with you is interpreting, it's more interpreting word problems. It's not anything really new, but let's look and see what types of things we'll see in Inventum. So interpreting a function, examine this word problem with me in the white box. The mass of a sample of radioactive materials in grams is represented by the function g of x is equal to 114 times 1/2 to the x power, where x is the number of years that have passed. So a couple questions below. Are we looking at growth or decay? How do we know? In the parentheses, we have this, 1/2. If this is bigger, greater than 1, it's growth. Just like we saw last week with our different exponential functions. Or if this is between 0 and 1, it's decay. So for this example, we have a half, 0.5. If I wrote it as a decimal, it would be 0.5. Same thing as a half, right? That's not bigger than 1. That's not growth. That must mean that for this example, we have decay. So that's what I want you looking for. What's in the parentheses? If it's 1 point something or a number bigger than 1, it's growth. And if it's something in between 0 and 1, like a half, it is decay. It's getting smaller and smaller. What is the initial amount? Can anyone tell me what the initial amount is based on the formula that they gave us in the black above? There's a number that's in that spot for the capital A. That's our initial amount. Can anyone tell me what that is? Okay, I see someone in the chat. Anaya, high five, Anaya. Boom. Yes, correct. She said 114 is the initial amount. It's whatever number is not in the, doesn't have the exponent. Whatever number is in the spot of the 114 here is the initial amount, that's starting amount. And then what is the percent change? This is a little tricky. I'm going to show you how we can figure this out. What does the formula start like without any numbers in it? I'm going to go back to that quick. Here it is. the formula in the parentheses, I mean, the whole thing is f of x equals a times all that. The percent change is just that part that's 1 plus r. It's just the r. Just the r is the percent change. So this is why it's a little tricky. What's in the parentheses total? It's 1 plus r. Just keep that in mind. 1 plus r is what's in those parentheses. So I'm going to write that out, 1 plus r, because they're asking us what is the percent change here. And what's in our actual parentheses in this problem? It's a half, 0.5. We can solve this little mini equation I just formed for r. We know that the parentheses is 1 plus r for all of our problems. And if you have a problem like this given to you with any number in the parentheses, you can set it equal to 1 plus r and solve for r to find the percent change. Now let's solve the equation. 1 plus r, drop the parentheses. We don't need them because there's nothing being multiplied outside it, right? So there's no need for those parentheses to group them. 1 plus r is equal to 0.5. Subtract 1 from both sides. 0.5 minus 1 is negative 0.5. So that means the percent change here is going down 0.5, negative 0.5, decreasing 0.5. And what is 0.5 as a percentage? We've done a lot of going from percent to decimal. My rate we just found is negative 0.5. Remember, the first two decimal places is the percentage. So looking at 0.5 here, 5 is part of that, and the next digit would be part of that. There's nothing written there for the next digit, is there? So that means it's an assumed 0, and that means this is negative 50% or decreasing 50%. Sorry about the purple. I hope you can see that. Okay. Okay, it's almost time to go already. That went by crazy fast. I want to show you one or two more examples. And we'll do it together. A non-native fern species is introduced into an area and quickly begins to spread. The number of plants can be modeled by the formula P of n is equal to 1,200 plants times 1.68 to the n, where n is the number of months. Remember, I told you that x power is always time, right? So in this case, they're just calling it n, but it means the same thing as x. That's our time since ferns were introduced. Use this information to complete the statements. Based on the model, there were initially how many ferns? It didn't tell us in the word problem, but looking at the equation, what's in the spot of A? 1,200, 1,200, right here. That's our starting amount. The monthly percent rate of change is what? The rate of change. Remember, they're asking us what is R. R is what? Rate of change, percent rate. So it's not 1.68. It's not everything in the parentheses, right? It's everything without that 1 plus. So here we have to kind of solve backwards or just think about it. Here's what's in my parentheses, but we want just the R. So if I were to drop my parentheses now for this mini equation and solve it for R, minusing 1 on both sides, what's left over? 0.68 is R. As a percentage, notice that, look at the left again. They want it in a percent, not as a decimal. So the first two digits are the percentage, 68. So that means this is 68%. The first two digits are the percentage. And then lastly, they want to know, is this growth or decay? Well, the rate is 68%. But looking at the whole value, how it started in the parentheses, it was 1.68. 1.68. So that means it's growth. That means the ferns are getting bigger. There's more and more and more of the ferns. How can we know that? Look back at the very top before I started even drawing. The whole value inside the parentheses is bigger than 1. Bigger than 1. 1.68. That's bigger than 1. So that means growth. And okay, it's almost 12. So I'm going to stop there for today. The homework, I hope whoever left gets this on the video. The homework is to do the third mastery test, modeling with exponential functions. This is required. Homework. Mastery test. Modeling with exponential functions. Sorry about this spelling. Exponential functions. Okay, I'm going to put the video onto YouTube again, and I'll send out a text when it's up in case you want to see it again. Just to clarify anything. Tomorrow's Tuesday, and I'll be able to work with you at 3 o'clock tomorrow afternoon for any extra math help, okay? Have a great day. Thanks, Savannah. Thank you for coming. Thank all of you for coming, and I'll see you tomorrow, okay?